Let's jump right in. Welcome to part 1 of our explainer on solving the Riemann hypothesis, the ontological shift. Today we're going to completely shatter how you understand computation, numbers, and honestly, maybe reality itself. Because before we even touch the world's most famous unsolved math problem, we have to totally rethink what a number actually is. So here's a massive question to kick things off. Does intelligence calculate, or does it just fit shapes together? We intuitively assume that intelligence, whether it's firing neurons in our brains or processing in a supercomputer, involves step-by-step mathematical calculation. We tend to picture problem solving as this sequential, energy-burning algorithm. But the reality of physics, and really the core of the Nexus framework we're exploring today, suggests something entirely different. True intelligence actually goes out of its way to avoid explicit calculation whenever it possibly can. Think about water, putting out a fire. When you throw water on some flames, the water doesn't sit there, boot up, and calculate some complex thermodynamic algorithm to stop the fire. No way. Instead, its molecular shape, its literal geometric structure, simply fits the query like a puzzle piece, breaking that heat loop. It's not a calculation, right? It's a query. The water's geometry is just structurally incompatible with the fire's geometry, so the fire stops. Problem solving, at its fundamental level, is essentially address recognition in a pre-sorted shape field. And this brings us to an absolutely brilliant concept, the substrate API. Real mathematical constants, things like pi, the natural logarithm base e, or the golden ratio phi, they aren't just human inventions. They're fundamental, free solution grooves literally carved into the universe. The universe doesn't invent pi every single time a raindrop or a bubble forms, it just samples a stable attractor. These constants are pre-compiled geometric shapes. Reality uses them to totally bypass doing explicit math from scratch. Usually, when we do high-level math, we just abstract the machine away. We treat symbols as these perfect, flawless things and ignore the physical implementation entirely. But the Nexus framework demands an ontological inversion, meaning we literally have to flip our entire worldview upside down. We need to look at how abstract logic maps all the way down through the formal code, into the machine memory, and right down to physical charge and heat. Because that physical implementation, the actual geometric limit of the substrate, that is where the truth actually leaks out. Math is basically just logic forced into a physical substrate. Section 1. The geometric fold machine. Data as physical shape. Let's get into it. Okay, so how do we actually apply this shape-fitting logic to raw data? Well, here's the mechanism in action. XOR nibble cone tomography. Instead of treating functions as abstract math, we're going to treat them as physical machines. Imagine taking a 32-byte sequence, let's say the exact hexadecimal sequence of pi. We split it into nibbles, which are just half bytes of data, and apply a logical sorting process called XOR reduction. Level by level, the data combines and folds. It forms this triangular cone that eventually collapses all the way down into a single apex nibble. So the geometric fold machine takes massive, complex sequences and continuously folds the geometry down into one single point. Now here is where it gets absolutely wild. The crucial point here revolves around the number 33. You might think that by folding 32 bytes of pi down to just a single nibble, we've basically destroyed the data, right? But we haven't. Not at all. The entire original sequence of pi is perfectly reconstructible from just two things, the trajectory of that cone's geometry and a 33-bit location key. Which leads us to a pretty mind-bending realization. All data exists simultaneously in all states. Location is the key. Think about it. You aren't generating pi through infinite, exhaustive calculations. By using that 33-bit address, you're simply querying its pre-existing shape inside a mathematical equivalence class. The sequence already exists as a shape in the substrate. You just need the exact coordinates to pull it out. It's kind of like having the exact Dewey Decimal coordinate for a book that the universe already wrote. Moving right along to Section 2, the 32-byte resonance and the pi over 9 attractor. So you might be wondering, why were we folding exactly 32 bytes earlier? Well, because when researchers analyze the mathematical constant E across different frame sizes, something magical actually happens. Its ambiguity normalizes perfectly to an equilibrium fold pressure attractor known as H, which equals pi over 9. If you test 16 bytes, or 64 bytes, or 128 bytes, the geometry just doesn't align. It is exclusively within the 32-byte frame that the structure of the constant E hits this perfect, undeniable geometric resonance.
This 32-byte or 256-bit scale isn't just some arbitrary truncation humans made up. It's a resonant geometry. It's the exact natural coordinate system where the architecture of numbers perfectly aligns. It's really no coincidence that our most secure cryptographic boundary, SHA-256, the exact math protecting your bank accounts and the entire internet, operates at exactly this 256-bit state width. This container size is a structural sweet spot where mathematical logic perfectly folds without any arbitrary distortion.
Section 3, targeting the Riemann hypothesis. Reframing it as a runtime safety theorem. Okay, now that we've totally reframed numbers as physical structural shapes, we can point this weapon at the ultimate mathematical boss. Traditionally, mathematicians approach the Riemann hypothesis by searching for abstract zeros on a complex graph, desperately trying to prove they all lie on a single critical line. The Nexus framework? It abandons that abstract graphing entirely. Instead, it reframes the Riemann hypothesis as a runtime safety theorem. We're testing the prime numbers as a closed computational metabolism. We are essentially checking if the prime number system is a perfectly balanced, self-sustaining engine. To actually pull this off requires a massive architecture. We've got the principal wheel mode, the geometric fold machine, the Hall residue, all working together as a single metabolic system. It's digesting prime mass, sorting the arithmetic exhaust, and mirroring it back to test for spectral stability. It's an incredible piece of machinery. And because we treat it as a physical machine, we can map its structure directly. The level reversal in our physical XOR fold machine maps perfectly to the abstract functional equations of the zeta function. And that midpoint level of our cone, it exactly matches the critical line, the famous seam, where all the zeros are supposed to live. Which brings us to the ultimate constraint, the Nexus RH arithmetic gate conjecture. In plain terms, this proposes a physical, geometric constraint on the prime numbers. It says that the system's geometric resonance can only be satisfied directly on that central mirror seam, where sigma equals 1/2. If this conjecture holds true, it proves something profound. If you step off that critical line, the geometry physically distorts, the math breaks, and the universe simply rejects the shape. So I'm going to leave you to ponder this quote right here. The Riemann hypothesis, read through the Nexus framework, is the statement that the completed zeta machine has no stable quartet defects. Think about that. What if the greatest mathematical mystery of our time isn't a complex equation waiting to be calculated step by step? What if, instead, it's a fundamental geometric shape waiting to be recognized in the universe's computational runtime? Keep fitting the shapes together, and I'll catch you in the next explainer.